video, I'll be showing you how to communicate between Pixie2 and myRIO using UART interface. This is how the wiring diagram looks like, referring to its datasheet, Pixie2 and myRIO. Let's continue in LabVIEW. So first, since we're using myRIO, I'll be using the myRIO palette, low level, and UART configuration board. So in my case, I'll be using the constant to set my configuration board. Then next I'll be selecting my baud rate. In my case, I'll be using 19,200, which is the same value as my setting in my Pixie2. And as for the data byte, I'll be using its default value, which is 8 in this case. Next, we will need the write function palette, so that we can request a packet from it, since Pixie2 need a request packet before receiving its response. So by wiring up it accordingly and setting up a control where we can string control for us to request our packet. As for next, we'll be using the read sub to read our data to receive our response from our Pixie2. For the byte count, I'll be using 2, just to show you every 2 byte how the value is going to appear and so on. And I'll be setting up a close. So once every time we configure it, we always need to close it. So just to show you on how the data is being received and flow, so I'll be using a while loop to show you how the data for every 2 bytes is being generated. In this, as well as using feedback loop, and as well as concatenate string to form the whole raw data. So here let us put a wait and put a 200 milliseconds, and as well as a stop to control our loop. So referring to our front panel and our data sheet, you can see that this is our data, that the response packet, the value that we need to send for this packet. So the packet I'm using is color connector component. For the value, we will need to set by using hexa value, and it's key according to Little Indian. So by referring to this datasheet, I will need to key in such as AEC1, and for 32 will be 20 in hexa, and as well as 2S02. So in my case, for the signature, I'll be using all, and as well for my maximum block, so it will be FF for 255 characters. So here you can see that this is our raw data. But according to each byte, you can see that which data belongs to which byte, and from there we can filter it and extract whichever data is needed. That's all from me. Thank you.